The Shepherd scope has two reticles, which move independently. The main crosshair is in the second focal plane and is always in the center of the view. The reticle with the circles is in the first focal plane. The tick marks on the right are minute of angle indicators, or MOA marks. This is also a bullet drop compensator, or BDC. Once you sight in at 100 yards, you are automatically sighted in at every range out to 1,000 yards. The bullet will drop through each circle at those ranges out to 1,000 yards. Different models are available for various calibers, including everything from .22 long rifle to the 50 caliber BMG. This is also a rangefinder because there are 18-inch circles at those ranges. An 18-inch target will fit exactly inside each circle at those ranges. Just fit and fire. It requires no dialing, no zooming, and no math. One advantage to this dual reticle is that you can easily adjust for a windage shot without having to count your clicks to return to zero. You can use the MOA marks at the top to know exactly how far you are adjusting for any windage shot. The main crosshair will always hold your zero position, so you will never need to wonder if you moved back to the zero position for your next shot. Simply move the circles back to the main crosshair to return to your zero position. Another advantage of the dual reticle is the one-shot sight-in. Keeping the crosshair where it is, simply move the circles to the right until they line up with the bullet hole. Then move them down until the small circle at the top is on the bullet hole. At this point you are sighted in, because this is where your gun is actually shooting. Then move the crosshair until it is also on the bullet hole. This simply brings the circles back to the center of the view. To understand the advantages of the Shepherd BDC reticle in the first focal plane, we will now look at the disadvantages of a typical BDC reticle in the second focal plane. Notice that as the view is zoomed in and out, the reticle is stationary. It does not move with the view. This causes the bullet to impact at different places on this reticle every time the zoom ring is turned. For example, let's assume that the lowest indicator marks the spot where the bullet is supposed to be at 500 yards. Watch this indicator as it moves up and down over the view. At what power is this indicator marking where the bullet will be at 500 yards? How can this reticle maintain any precision in compensating for bullet drop when it does not stay on target as the zoom ring is moved? Other important questions are, what bullet is this reticle calibrated for? Does this reticle match the drop figures of your caliber and bullet? Are the drop figures available for this BDC as they change with each zoom power? At what power are the indicators accurate? Without answers to these questions, precision in accuracy will be very limited. In the Shepherd scope, the reticle with the circles is in the first focal plane. Notice that as the view is zoomed in and out, the reticle moves with the view. Keep your eye on any of the circles as the view zooms in and out. Each circle stays in the same place on the target. This means the bullet will impact in the same place along the BDC reticle regardless of the zoom power. Shepherd scopes have many different models to match different calibers and bullets. The drop figures for each scope are given so that greater precision can be attained with different bullets. The drop figures do not change as the view zooms in and out. The circles are accurate at every range regardless of the zoom power. There it is. I went through it so fast it took it a second to knock it down. Not 100. You ready on the 100? First big circle, 100. Put it right on the crosshair. Beautiful. Excellent. 150. Good shot. Got it. Got it! Yeah!